Hello and welcome to another video. This video is on Bevy 0.11. So it came out last night and I've actually for the first time had a recording session blocked up for when it came out, like unintentionally. I was doing another video that I now have to change some of the details in because 11's come out, which means that some of the details are no longer accurate because it happened to just sort of touch on what I was covering. But this update, at least in this section, doesn't look as big as the previous updates, but just has so much detail put around what they changed that it's pretty incredible. But sadly, it doesn't seem to have very much in it that I'm personally super excited about. There were some things that I'm like, oh yeah, they're going to be great for what everyone else is going to do, but nothing that I'm like, man, I'm glad that's added for my project. But anyway, we'll jump right into it. We've got screen space occlusion, which is the idea of basically shadows cast by the camera in the sense that it's ambient light, not light from a specific light source. And so it casts shadows sort of from the perspective of the camera. So the most obvious spot I found for it is this little green flag here, or drape, is that as you go over it, you can see it's very flatly lit in the old style, and then screen space occlusion, it gives it nice like riffle shadows. And the idea is that these shadows are actually calculated based on how the camera's looking at it. So the fact that we're looking at it this way, it can work out that this would be blocked by a light coming from the camera. Whereas if we were looking at it square on, the light coming from the camera wouldn't block any. So it's why it's screen space, is that it's light from the camera block. Here's just a cutout of what all the screen space looks like. And it basically, the screen space occlusion uses the ambient light and environment maps. So if you use a Skybox, it'll also cast shadows from that. They've added Temporal Anti-Aliasing, which, to be perfectly honest, the only difference I can really see between these two is that the little chord here has lost its holes in it. And I believe this is because Temporal Anti-Aliasing is the idea that you keep the previous 2 frames, I think, because it says somewhere you need 2 additional frames worth of memory. So it keeps the previous frames, and then we'll and a direction vector or something, and basically we'll average or like anti-alias using the previous 2 frames as opposed to the adjacent pixels, which is what the multi-sampling does. And this means that you'll end up sort of applying like a motion blur to the picture over time. So if it's sitting still, the anti-aliasing will leave crisp lines, but if it's moving, the anti-aliasing will actually smooth things, which I think is what's happening here. Is I believe this image is probably spinning, so these holes appear on the multi-sample, but they disappear on the time because as it moves, it sort of blends over those holes. They talk about the different multi-samplings they have, so the different anti-aliasing. So they have multi-sampling, which just basically takes multiple points around an area to work out like an edge and smooth it. Then there's the fast approximate, which just sort of blurs the edges of objects so you can't tell that they're not perfect edges. And then temporal, which as a sort of effect, as it says, you can get ghosting, which is the idea that if something moves, it can leave a trail since that will be blended between previous frames. And because the previous frame, or like the current frame has the previous frames blended into it, it means that the next frame will have whatever blended into it, and it sort of ghosts away over time. They say it's really good for temporal flickering, which is the idea that if you have lots of really fine details, like at the edge of a shadow of a forest, where there's all these leaves or something, it'll flicker at certain points because the sampling will pick different points each time, so they'll flicker if they're like less than a pixel wide. Like, or if the gaps are like, exactly a pixel wide, and the temporal will smooth that out because it'll know the previous frame it was dark and this frame it's light, so it should probably still be dark. And they talk about the pros and cons about multi-sampling is slow, approximate is inaccurate, and temporal takes a larger memory footprint and has ghosting artifacts, but fixes other types of artifacts. They talk about the sharpening, because multi-sampling actually samples an edge multiple times, means that you'll keep sharp edges, whereas the approximate sort of smudges edges, and the temporal will smudge edges if they wibble wobble. So they've added a sharpening pass that you can do that will sharpen the edges, which for me is a little bit weird because you can barely tell on any of the image what actually changes. Like nothing to me is changing, except I think down here you can see that it actually sort of anti-aliases it because it sharpens the edge back up, but in a way that like adds some pixelating back in. But maybe that's just in my head. It really can't tell the difference either way on this. But I think if the image was spinning, the blurring would become more apparent and then the sharpening would be more obvious. They've added morph targets. This is one of those things that I'm like really excited to see what other people do, but have no intention of using myself. And morph targets are just your, instead of using bones to control meshes, you can specify like, this is the default position for the mesh, and then be like, this morph moves these vertexes this much. And so you can do like facial animations. So basically by morphing the smirk, you can change how the face looks. And then you can also blend multiple morphs. So you can blend the smirk and the frown together to create unique faces. It's how things like VR chat do their speaking animations, is that each mouth shape has a morph, and then it blends between the default and the morph that you're currently saying, and then from like that morph to the next morph, based on like what syllable it thinks you're making. And then they just sort of explain that you have your default, your frown, your smirk, and then it just sort of weight blends them between, so you can have combinations. You access it through a morph weights component that it's attached to your entity, and so you can morph them really easily. Next is Parallax maps. This is something that I might see myself using, depending. I've never created a normal map, so I don't know why I think I'd be able to make a parallax map. But I was thinking it'd be really cool to do like a Minecraft clone with this, but like it suggests down here, cobblestone is usually where you use it. Where's their big picture? So this is normal mapped, this is parallax mapped, and normal mapped. So it ends up with this really cool feature, and it gives like a 3D effect without needing actual 3D meshes. So I was thinking a Minecraft clone where the walls have parallax maps would be really cool to do, and is something on my to-do list. But anyway, let's watch this little video. So this is showing the top half has a parallax map on it, and will actually change the height of the mountains based on what the parallax map says they are, or the height map. And we'll have a parallaxing effect, as in pixels closer to the screen will move faster than pixels further away. There versus the normal map, which only corrects for lighting. And this is all done with, I think it says a vertex sphere of like 600 vertexes, rather than needing to have like a, what you normally do with height maps, where you distort each pixel based on the height, or each vertex based on the height map, and therefore need enough vertexes. There is 648. So yeah, if you do it with vertexes, you need enough vertexes to basically get the level of detail you want, whereas the this map is done on a per pixel level based on the resolution of your map. So you don't have to have millions of vertexes to do a million pixel image. You can just have a million pixel image and correct each pixel accordingly. So yeah, they're talking about one of the places you can use it is cobblestones. So they have the cobblestone wall, and then so it looks boring. Then they added a normal map, and then they add a parallax map. And it's saying that the way it does it is it basically on a normal, your gray and your white of the two different reflection angles of the normal are right next to each other, whereas on the parallax map you actually tell it that when it's rendering this, it should be actually lower, and it will physically push the pixels back in the depth map, so other things can also know that you've pushed the pixel behind them and therefore render in front, sort of thing. And so it just relies on the fact that you're already calculating depth, you're just adding on top. So you don't need geometry to tell it this, just a map. Bevy finally supports skyboxes. I think it had the capacity to load the files, but it didn't have built-in functionality. Now you can attach a skybox to a camera and it'll have a skybox around it. We've got WebGPU support, which apparently gives us access to compute shaders on the web, and a whole bunch of other functionalities. They talk about like the examples you can do, and just how it gives you more versatility because it gives you access to the GPU from web browsers. And they've improved shaders by using Naga oil, which I love that name, snake oil. And so this works by like scoping variables and all sorts of stuff. Like it breaks it down into modules, and will actually give you errors of where exactly in the collection of files that you've turned into a single shader you can find things. It also talks about allowing for like hooks and overrides and stuff so that you can override a specific function or a hook into a specific point in a shader without needing to directly be able to interface with the shader. UI buttons now have borders. I mean, they look incredible. I'm looking forward to using this in just general UI use, just having nice little borders around my buttons without needing to have that fancy, like you need a second button behind or a second node behind that's slightly larger so that you can get the outline. Instead, it's pre-built in now. And I don't know how you can configure this, but apparently you can actually specify like each border side, or I guess which sides have borders. Oh yeah, there's your borders rect all. And so you can specify, you know, which sides have borders and how thick each border is on each side. Grid layouts, again, I guess this is something I would actually think I'd be using is a grid layout. One of the few things I've missed from Unity is to be able to be like, I want these things laid out in a grid and be able to actually get them in a nice grid. So that's going to be fun. It does seem a bit complicated in order to lay them out, but that's most UI. Hopefully in the next couple of days, Belly will update and have grids by default because, you know, it's built into base Bevy, so all they're really doing is giving an interface to it. So this is probably one of the few things, the schedule first ECS API is one of the few things I feel like Bevy, like the API is definitely a step forward, but the fact that they've split the schedules back out into schedules and removed base sets feels like a step backwards to me. Like, I understand why they did it, is what ended up happening is people were ordering their systems in the wrong order. Like, too many implicit confliction. Configuration, no. Adding system schedules wasn't economic, no. Somewhere they've got, they talk about, like, people were talking, the base set ordering was wrong. So people were obviously trying to put things in the post-update and saying that they need to happen before things in the update. And because it's all one schedule, it's like, oh yeah, you can do that. And then would go, I can't actually work out a way of putting the thing that has to run after before the thing that you've, you know. So from what I understand is that they've basically just gone back to 0.9's approach of having schedules and a different schedule for each stage as opposed to how it was in 0.10 where it was all in one schedule and everything ran sort of accordingly. Now it's split back out like that, which again doesn't really make a difference because it's not like them all being in the same schedule had any use case for talking across stage boundaries outside of things that didn't need world access. But again, because they had specific breakpoints, like at the end of each quote unquote stage, you had to wait for every system to finish because it needed to run the command flush. So it became one of those, like, splitting it back up doesn't really make any tangible difference. It just feels like they did something in, they added something in just feels like they added something in 0.10 and then took it out in 0.11 because it confused people too much. But this is probably the better approach and the approach they probably should have gone from the beginning. So what they're talking about is that one of the things they've done is removed this is the base set one that I was looking for. They've removed a whole bunch of different ways to do things because there was, like, according to this, 6 different ways you could add something to the startup system, which is just too many ways. I disagree with that approach. I think having lots of ways to do it is good as long as, like, you know, they are distinctly different ways to do it. Whereas some of these ones I agree. It's like you could go add a startup system, or you could tell a system it's on startup, or you could tell a system it's in schedule on startup. There were three ways of doing the same thing in the same place. So I agree taking those out, but I don't think having multiple different ways to do the same thing, as long as they all end up doing the same thing under the hood, was a problem. But they're also saying that one of the issues is it abstracted away the startup set entirely, so people didn't even realize what they were actually doing. Apparently there was too much implicit configuration, which I haven't quite worked out how this actually cuts down on that, because you can still say add to system and it's still added to the default schedule. But what they're saying is basically they're not going to give any configuration whatsoever beyond the bare minimum to get Bevy to run properly. and you will have to add your configuration from now on, whereas apparently in 0.10 there was sort of enough configuration that it wasn't necessary, and it was just to do things certain ways. And then adding systems to schedules wasn't ergonomic, so you used to have to go add system, foo.inSchedule, and then specify what schedule it was in. Now they've changed it to you just add systems. It's down here. So you add systems, and then you specify what schedule it's in, and then either a single system, a tuple of systems or a nested set of systems that you want to add to that specified schedule. The other thing is that they've also really advanced the combinations. So you can have a tuple inside a tuple inside a tuple of sets. So here's your outside tuple, and then you've got this tuple, and then this tuple in that one, and then this. And basically it talks about if you were to run this, or I guess this one where they've actually given them names, it would run attack and defense in parallel, and then run health check, and then run the handle death and respawn after the health check. And what it's saying is you could write that out explicitly, that all happens in order, or you could connect them all in a tuple and then call chain, which plays them in that particular order. So first, second, third. And then it also says you can do even more nesting, in that you could have A and then CD, BCD in a chain. So B will then will run before C, which will run before D, but all three will run in parallel to A. And then once they're both finished, E and F can run in parallel. So it sounds confusing, but it's really useful for structuring your running order, without needing to go in and individually configure things for each system. You can actually structure it in a readable way before you insert the system. So this is useful for people with complex applications, but not so useful for me because I have yet to make anything more complicated than Pong. So they've added Gizmos. Gizmos is what they refers to as immediate mode drawing. So it basically means that when you tell Bevy to draw, when it gets to the render stage, it'll draw all the gizmos, and then the next frame it'll not draw the gizmos. So if you stop telling it to draw the gizmo, it won't draw it. So you need to tell it to draw the gizmo every frame. So this means that if you fired rays, you could have them appear for a single frame and disappear, or keep being redrawn. But you don't have to remember to clean up the gizmos. You just stop telling them to draw, and they'll go away. It also says that they're batched, so they're very cheap to draw. So you can draw hundreds of thousands of gizmos. So don't worry about cluttering the screen in debug mode, because it's not really going to have an impact on performance. The ECS Audio API is another really neat thing for people that have audio in their games, but not that useful for me. But basically, in old Bevy, you used to have to access resources and assets and everything in order to start and stop your music from playing. But it's been changed into entity components now. So you insert a audio bundle, it will load it all up and get it working, and then the audio sync is actually attached directly to the component instead of in its own resource. So you no longer need to get resources and the handle and then look it up. You can just query the component off of the entity holding it, and you'll have access to it. So that does mean to have global audio, you'd probably have to have an audio entity, like Thunder or something like that would have to be an entity that is global as opposed to a specific entity that is making that sound. Then there's global audio volume, is just a new resource that you can use to scale the global audio volume. Pretty straightforward. Resources are now supported in scenes. This is something pretty phenomenal. I don't know why they didn't add it when they changed the scene format, because again, they deliberately left it open to be there. They made it named as opposed to just a array. But the primary thing is you can now use reflected resources and have them inside scenes. So you could load up a game, save, and it will keep their score or keep their points or their achievements, their life, and all that. So you can now basically load and use scenes as save files more than they were components of larger worlds in previous versions. You can use scene filtering, which basically allows you to specify when you make a dynamic scene of what components are allowed or what components aren't. not allowed to be serialized. So this will, one, allow you to have components that don't get saved in scenes, whereas before it was just like they would just be rejected because they couldn't be saved and skipped. Now you can specifically go like, I know this can be saved, but I don't want you to save it. And so that'll be useful, again, for making like save games where certain aspects don't necessarily need to be saved to disk, but need to be serializable for networking reasons or something. So Bevy now has a default font. I believe you can customize which font is default, but it also then has a further font provided by Bevy. So basically you can configure the default font, or you can just use the embedded default font, which is going to be great for people like me that are like, I just need text on the screen. I don't care what it looks like. Great use. UI textures can now use atlases. So let me just run this little example. So this is a sprite sheet as opposed to previous versions of Bevy. You could only use solid images, like full complete images for UI. And they said that basically they were already having to use texture atlasing for text. So they just expanded on that to allow for texture atlasing with UI images. So we got GamePad Rumble API. Apparently, Bevy in the past has Grimmel's crate, which let you rumble controllers, but it was very complicated to order to actually be able to interact with. So now there's just events. So you can say GamePad Rumble, start rumbling for 5 seconds at maximum power, and it will take care of it under the hood, which is nice. Again, just I really appreciate when Bevy expands the features and functionalities, even if I have no intention of using them. This is like, it'll draw more people to want to use Bevy, which will only be good for Bevy in the long term, especially my channel. Yeah, wink, wink, nudge, nudge. There's a new default tone map, which I think Bevy really needed this. I feel a bit weird that it's taken these glossy ones at the back and really dulled them down to basically the same as the one at the front. But the big one that I notice, less so on my computer, but definitely on my phone, is that this looks very purple. And when you drag it over, it goes to looking like what I would expect that ball to look like. But I do not appreciate that the glossy ones at the back also get matted like the ones at the front. Like there's no distinction between these on my computer. But that could be my computer settings, because I think on my phone, it just dulled them down. It didn't make them as flat. But again, it's just sort of that. I appreciate that they've made this purple one less noticeable, but I don't like that it seems to kill all the tone in the background. Like it all gets very flat. But I guess also another thing is it splits these into two different pinks. Here they look like the same pink. Anyway, that's a tone map. If you use them, great. I don't use them. So you can now query for entity refs, which is really useful for if you want to make like scripting and dynamic querying, because it means that you don't need to know what components you're querying before you query. You can literally just query for absolutely anything. Or if you want this system to not conflict with absolutely everything in your world, you can query for with player or without player, and then do different functionality like that. It's because it says they conflict, so you can't query for an entity for the players and the enemies at the same time. So you have to do that. But this also means that it allows you to do like script items and non-script items, and have all your systems run on non-script things much faster, but the script items can still run. I think entity ref and script is going to go like hand in hand. It's pretty impressive. They also say, where is the with thing? I don't know if I skipped over it, or I found that this update list isn't as nicely ordered. Like it'll be talking about entity refs, and then it talks about the screenshot API, and I feel like in a second it's going to talk about the with component. It definitely does it with reflect. Is it like talks about reflect, then splits into something else? It's not like my brain's anymore coherent, but it'll talk about reflect, it'll talk about something else, and then it'll start talking about reflect again. I'm just going to quickly make sure I didn't miss it. No, it has. Oh, it took me to it. Okay, so that's definitely below. So the fact that they talk about the new like ECS APIs and then talk about other stuff and then go back. Anyway, back on track. Very sidetracked there. So screenshots. Bevy can now without any external plugins, take screenshots. This would be very useful for me if I ever got around to building my video editor in Bevy, where so I can basically just do the same thing as Motion Canva, but using Bevy. But yeah, it just lets you specify, I want you to take a screenshot. I believe Bevy added this so that they can improve their example QI testing, like automated testing thing. So basically, Bevy can run the example, take a screenshot at certain points, and then run like an algorithm to compare them to what the baseline was to make sure that things don't break. So taking screenshots is important for bug testing, but it's just a default feature that you have now for players to be able to take screenshots in your games. Like, it's just Bevy needed it. They gave us access rather than keeping it locked behind a for developers of the engine window sort of thing. Render target texture view. Oh, my brain's gone slow. This is just allowing for you to specify the camera's render target as being a texture view in WGPU, which apparently allows for VR support. And I'm super excited. I can't wait until I go on Bevy's page and find a crate that lets me make a VR experience in Bevy, because that would be incredible. Anyway, so they've improved text wrapping. So basically what used to happen is that the text would be rendered before the size was calculated. This means that if you sent something like auto or grow or anything like that with text in it, the text would never wrap, because the what the text was on wouldn't have a specified size, so the text wouldn't know when to wrap until after. Then the thing would change its size, and the text, has already been rendered. So now it pre-calculates what the text will look like before rendering the size and shape of the box and then the text. Faster UI render batching. So apparently the way that this works is it can create batches of so when it renders something to the screen, it renders it in batches of things that use the same texture. And now they're like, hey, this thing's untextured, so we're going to say it uses the same texture as you and batch them together. And they're saying their many buttons example goes from taking like 10 milliseconds to render, or I guess 9, down to like a few microseconds or nanoseconds or whatever that. No, it's micro. Milli-micro? I don't know. But basically, it's orders and orders of magnitude. Because the other thing to remember is this is logarithmic. So here's 1 to 10, and this is 0.1 to 0.10. So like this is a huge speed up in that it's like 3 orders of magnitude faster sort of thing. Bevy reflect proxies. So Bevy has the dynamic types, and it just basically saying that they had some issues because they used to just use the type name in order to alias themselves as being like, I am this type, even though I'm a dynamic representation of it. Now, I think they haven't done it yet, but in the future it will take the type info, like they've put the structure in place, so it can copy the whole type information and therefore pretend on a greater level to be the dynamic, like the physical concrete type that it's dynamically representing. I don't remember what the fancy term they used. Anyway, yeah, so when it's pretending to be underlying type, it will have more information about the underlying type more than just its name. So from reflect ergonomics is from reflect no longer needs to be independently derived. Now, by default, Bevy reflect will implement from reflect and register the from reflect data. So you can now convert a dynamic reflect into a concrete type much more easily. You can also tell it not to implement from reflect, and I believe there was some other functionality that you could believe, but that will come up later. I think that was related to something else. You'll see in a minute. Deref derive attribute. So Bevy talks about how it likes new type pattern, and that's basically to do with if you want to store a score, you can't just put an i32 in. You've got to wrap it in a score that then you access the i32 internal. And Bevy has a deref and deref mute derives for that, so that you can easily get access to it without needing to implement them directly yourself. And it's only ever worked on structs with a single field. But now you can specify on structs with multiple fields which field the deref will actually refer to when you call deref, which they're saying this works well for generic types. So you can specify the health is what derefs to, even though you have phantom data, or you could have a whole bunch of other stuff. So it's like, when I deref this, it is this, but otherwise I have this other information like helper information. Another example where this could be theoretically implemented, though Bevy will never do it, it's something you'd do, is with time, is you could have like the delta time be the deref value, and then, you know, you still have access to your, you know, elapsed time and your delta seconds and whatnot. So it's like, when you deref, you get this value, but you can still access the other helper information surrounding it. The render graph has been simplified, or at least the construction of it. So they're saying there's a lot of boilerplate to adding a node to the render graph. So now you can use, what do they call it? The view node runner, which will automatically calculate and set up all the other nodes that you need in relation to allowing your node to run. And then you just need to make sure that your node implements default or from world so that Bevy can create it when it inserts it. This is what I mean, how we were talking about reflect, and then we talked about some other stuff and we're talking about reflect again. You can now reflect default. This means that you can specify on a reflect, like this enum with this data, you can say that the A value is default. So when a struct is created, the from reflect, on your dynamic enum, if it finds B, it sets B. If it doesn't find B, it fails. But if it finds A, it sets A. If it doesn't find A, it uses default. So that's what the reflect default's about, is saying like, if you don't find this data, just use the default value. It's not an error if this data's missing. There's delayed asset hot reloading. So apparently there was an issue in the file detection in relation to some systems, I guess, would fire their this file's been changed before they finished writing to it or something. I don't know. It said that it could cause issues reloading assets if they reload too quickly. So now there's a 50 millisecond delay between an asset getting changed and the server actually attempting to reload it. You can now use custom GLTF vertex attributes. I don't really use GLTF much, but you can apparently configure the plugin in order to extract custom attributes. So I guess that would mean if you wanted to have wouldn't be materials, like maybe pathfinding related information on the mesh, like whether a entity is a valid pathfinding, a vertex is a valid part of a pathfinding mesh, or whether it's not. I guess you could include that, or other attributes. I'm not quite sure. Again, don't really do much rendering. They've decided to change to stable path type paths. So originally Bevy uses std any type name and would just basically say, if it changes in the future, it's not our problem. Like we're not going to guarantee that these will be solid. But they've since decided, because of things like short names and sometimes you want to keep the internals of your structure and create private, because otherwise the names get ridiculously long ridiculously quickly. So now there's a type name struct that you can either automatically, I click something, that will automatically be derived with reflect. So if you implement reflect, you will automatically get type path, or you can implement it manually. I believe you can also like specify derive type path and then specify what the type path is. And this will mean that you can now use type path to get the entire path, short type path, which will just get the struct or the enum's name. You can say, I just want the crate's name. So you could have functionality that like detects mods, because it's like, this is a different crate, so it's not, core. I'm trying to think, like in RimWorld, there's a mod that like will tell you what mod an item comes from. That's where you'd probably use something like this. So you can now work out the name. It's like, oh, this thing, where does it come from? Get the crate's name. And there's also the module path, so you can get the full path without the file extension. There's also, I believe, other ones. But there's also, it says it works on generics. So like option will return, like if you type short, it will return that. And if you type in, type ident is another option. But that might be specific to options. But like, so it says it's an option, which I think would mean that like if you had type, open and close T, the type ident would say type without the generics included. I'm assuming the ident is without generics. So yeah, then you can specify your own custom type path. Bevy is currently working on porting it, so it won't be until 0.12 that Bevy will fundamentally reach that situation. Now we're on run conditions. So if it is now possible to add run conditions to tuple tuple systems. So this means that you can say, like, on update, I want run and jump to both be in a run if in schedule. So it's just, again, it expands on the ability to tupleize systems. And so apparently it'll also only evaluate this run condition once, which it says allows us to remove the on update system set from states, which were previously used to run groups of systems. So basically, if you wanted a system to run, you'd have to put them all in the same on update. But now you can say in state, which a little bit confusing to me because I don't know what the difference between them is, except this one's like an auto-generated one. But I guess, in set on update would be just as useful. I'm not quite sure why they're saying they need to do this, but the important thing is you can tuple them and apply the run condition to the tuple rather than having to individually specify different factors. So this is the has query that I was looking at, and I'm saying we were talking about their changes to the query API, and then they talked about something else for a while, and then came back to the query API. Anyway, so you can now query has component, which is very similar to currently even, where you can wrap a component in an option, and it will return none if it doesn't have that component, and some and that component if it does. The has is just a faster way and a non-containing way, like you don't lock yourself in. So you can now have like different behavior, like you could say has health bar or something on a player, and then if a player doesn't have a health bar, spawn the health bar in, otherwise subtract some health, and therefore only add a component at a specific point. But you don't need to lock other systems from being able to access the component because you've got a mutable reference or whatnot. It'll also be probably faster than the other one because it was saying in previous updates they've talked about if you've got a option, it actually has to make sort of like two queries, one with, one without. And if you add like two sets of options, now you've got four because you've got both the first one, the second one, or neither. So it exponentially grew the number of possible queries that it had to collect in order to give to you, which slowed things down, or increased conflicts, I guess is another way of looking at it. So the has is just a nice way of being like, it's a primary query, not a filter, and we'll just say like, yes, that thing has it, no it doesn't, without locking you to accessing that data. Okay, so you can also now have to derive events. This is, again, just to pull events in line with the rest of Bevy's structure. So originally, back in like Bevy 0.5, you didn't have to specify it was a component. Anything could be a component. Then they said, no, you have to tell us that this is going to be a component. Then anything could be a resource since Bevy's inception. I think it was 0.6. They went, no, you have to tell us it's a resource. Now in 0.11, they're like, no, you have to tell us it's an event. Because again, events could be anything. Now they have to be a specific thing. And they're saying that this doesn't currently do anything outside of, bring it in line with self-documenting, and, so it makes it easier to read. You're like, oh, this is an event because it's specified as an event. But it's more about in the future when they add an event storage type. So they might have a dedicated area for storing events, and declaring it as an event will allow it to do that, which is, again, part of the reason they did it to components is that you could then specify it was a table or a sparse collection of entities that could have that component, and resources are already stored in their own independent thing. They used to be a special entity that contained all the resources, but then they split it off into its own storage, and eventually they'll do that with events, I guess. So there's they added a cubic curve example, a size constraint example. So the cubic curve example is just, I guess, a 3D example of how to draw a curved line and make something move along that line. The size constraint example is something really useful for people that don't understand Reflect and want to learn is it lets you specify like different values and shows you what it will look like as a slider. So you can specify the minimum size, the flex base. So I guess auto, it starts at the end. 0 will start at the end, and then 25% will start quarter of the way. Size, it's 75%. I guess you're about to click 75%. So it's an auto at the moment, whereas if you clicked 75%, it would fill 75% of the way, whereas minimum size is like, doesn't matter what your size is set to, it'll always be 25%. And then maximum size, you could set like 50%, and then say size is 75%, and it'll only fill 50%. It's just about like being able to explore how the flex settings or the CSS style things interact with each other. There's a display visibility example, so you can see as you click each node what. Okay, so this is what it looks like, and then these are the settings, so you can like change what it does. So I think from like reading down this little section is if you disable their display, like if their display is none, they're not even calculated in terms of like where the layer is. So I don't know how that would affect this. Like if you turned off this outermost layer, I think they would all snap up into that corner because this layer is off, even though it's still there, it's not calculated size-wise. Whereas if you turned it to hidden, it's still there, like they will still consider it to exist. They just will, I guess it will also hide everything below it, but like for calculation purposes, it exists. It's just, it won't be rendered. So yeah, you could set like one of these to visible and you would still see it in its correct spot. Whereas if you turn one of these to none or display none, it literally doesn't get considered in the calculations. Anyway. Onward, No More Boris, which is the like bot that they used in order to manage pull requests, and make sure that everything worked seamlessly with each other. Basically, GitHub added functionality for this same behavior built in. So they've decided instead of using a third-party plugin, use GitHub's built-in one. They've added some new CI jobs, mostly around making sure that mobile works. This is what I was talking about earlier. So it'll run physically on a mobile phone, like iOS and Android device. So this means that even if the compiler doesn't catch it, it's physically running the hardware. Then they've added the ability to take screenshots and compare them so you can visibly see that the results are not working properly. And then a job that leaves pull requests for missing features and examples. So what's next is apparently the really exciting asset v2. So they're going to change how like the whole sort of system works. So it'll allow you for pre-processing. So that's like you could say like, oh, anytime an image loads, I want you to make thumbnails of the image, or at least I think that's what asset pre-processing is. Then they've also got optional asset.metadata files. So you could specify things like if it's a sprite sheet, you could specify the sprite sheet settings in the metadata file and have it load it as a sprite sheet as opposed to just a image that then needs to be loaded as a sprite sheet as well. Recursive asset dependencies, asset async asset IO, better asset handles, more efficient asset storage, just all around the place better. They're saying it almost made it into 0.11, but it just wasn't quite done. They've also got the PBR material light transmission. I don't really know what this is. I think it's just about like making so it's about making like transparent materials, but looking at like glass, plastic, liquid, gels. And apparently again, this is also basically done. The time anti-aliasing has apparently got some improvements coming, so a number of changes to improve its quality, speed, and support within the engine. GPU picking, efficient and correctly select entities on the GPU by using color IDs to identify meshes in renders. So from what I understand, GPU picking is the idea that when you render the screen, you render a second copy of the screen where every object that renders has a unique color. And that means that when you click, you actually work out where they clicked on this second image that you've rendered. And based on the color that they clicked, you immediately know exactly what entity they clicked because every color is unique. PCF direction and spotlight shadows, so it's just more lighting stuff. UR node border radius and shadows. Ooh, that sounds fun. So that's going to be like corners will be rounded and you'll have like a shadow that comes behind without again adding an extra entity that is that shadow. Diffuse rendering. Bevy already does mixed mode forward rendering. So I guess this is rendering that allows for like light to spread out, and so a spotlight, even though it only lights up a set area, will sort of also make the whole room slightly brighter, I think is what diffuse rendering is. Or it's rendering behind glass, because I vaguely remember something about like the big thing about Bevy 10 was that diffuse rendering, and their picture was a campfire, like a video of a campfire behind stained glass. So it might just be very similar to this material light transmission. Anyway, I hope you've enjoyed this video. It's a hell of a video to make. Not as long as the last one. The last one was like an hour and a half. This one's only 45 minutes. But there's a lot of cool and interesting stuff in here. I hope you've enjoyed my rambling on, and keep your eyes out for the next video that I need to now work and tweak a little bit before I upload. So I will see you then.